Hi, this is Miss Park. We're going to learn now what to do with exponents when they're fractions. So this page starts with a little bit of a review of just integer exponents. So let's do that real quick. Okay, the fraction 3/4 to the exponent -2. So we know when the exponent is negative, that is going to be the reciprocal raised to the positive exponent. So here's my reciprocal. And here's the positive exponent. So now I'm going to have 4 squared divided by 3 squared. So I'm going to square the numerator and square the denominator. Next one, -6 to the exponent 0. Anything to the exponent 0 is 1. And 2 to the exponent -3 is 1 over 2 to the 3. So now when I do this division, I have 1 divided by a fraction. So that is 1 times 2 to the 3 over 1. And that is just 2 to the 3, which is 8. Okay, this one over here, 2 to the -4 plus 2 to the -6 divided by 2 to the -3. There's not a whole lot I can do. I cannot reduce by 2's. Can't do that because they're bases in power. So I can convert everything to fractions. So 2 to the -4 is 1 over 2 to the +4, which is 1 over 16. 2 to the -6 is 1 over 2 to the +6, so 1 over 64. 2 to the -3 is 1 over 2 to the +3, so that's 1 over 8. And I can work with common denominators here. So up above, I've got 64. I can make them all 64. I'll keep that one. Let's see if we need it. And this is a 4 plus 1. And so that gives me 5 over 64 divided by 1/8, which is 5 over 64 times 8 over 1. I can reduce diagonally, and I'm left with 5 over 8. Okay, so there's nothing much I can really do. There are some neat factoring things I can do, like I can factor out a 2 to the -6. It's the smaller of these two. Factor that out and then maybe reduce somehow with a denominator. So there are things we can do with factoring and exponent laws. But the important thing is to understand we cannot be dividing powers here, cannot be subtracting exponents, cannot be adding exponents because there is this plus here and we can't be working with just the pieces. Okay, so here's the new thing, fraction exponents, okay, otherwise known as rational exponents. So we saw the word rational before from rational expressions. Rational just means can be written as a fraction. Can be written as a fraction. Okay, so let's see what that means. So if you see a fraction, so like this one, x to the exponent 1 over n, that is the nth root. So let's say, for example, x is 64 to the exponent 1/2. That is called the square root. So when we talk about square root, we don't usually write the little 2, but there is a little 2 there. It's the square root of 64. It means some number that when you multiply it by itself, so that there's 2 of them multiplied, you get 64, and that number is 8. Okay, let's do it again. This -27 to the exponent 1/3, this is called the cube root of -27. It means some number that when you multiply it by itself, 3 of them, you get -27. Notice it's okay to put the negative under the root sign because it's not the square root, it's the cube root. So I'm not looking for 2 numbers that multiply to give a negative. I'm looking for 3 numbers that multiply to give a negative. And that will happen when one of them's negative. Or sorry, well, they're all the same, right? So when that number is negative. So the cube root of -27 is -3 because -3 to the exponent 3 is -27. So I'm just going to write that here. Okay, so we're looking for a number that when you multiply 3 of them together, you get -27, right? So -8 we're looking for a number that when you multiply 3 of them together, you get -8. So that number, it's going to be the cube root, okay, of -8. But notice that this is a negative exponent. So with the negative exponent, I'll remind you, this is just the reciprocal with the positive exponent. Right? So you don't do anything with this -1/3 in terms of like taking the reciprocal of it or anything like that. It's the base that you take the reciprocal of. So here we have, this is 1 over the cube root of -8. And what number times itself? 3 of them gives you -8. That would be -2. So it's 1 over -2. And if you don't like to put the negative in the denominator, we prefer to have it either in the front or with the numerator. Okay, so that's the meaning of the fraction exponent. Now, what if you have, so up here it's giving us a few more rules, but let's go straight to the example and we'll see what to do with these rules. So what if you have something that looks like this, that is 4/3? So it's not 1/3, right? Because we saw with 1/3 it's a cube root, with 1/2 it's a square root. It's got like other stuff in it. So all we have to do is we have to remember the rule that says a power raised to an exponent, you multiply the exponents. And we're going to apply that rule backwards. So what I'm going to do is I'm going to rewrite this. I'm going to split the 4/3 into 2 parts. I'm going to split it into 1/3 on the inside, and I'll put square brackets, and put the 4 on the outside. Notice that this is the same as the line above, because to simplify this, I would be multiplying these 2 exponents, and I get 4/3. The reason I did that is because -8 to the 1/3, that is the cube root of -8. That's easy to figure out because I've already done it. I have it up here. The cube root of -8 is -2. So this now is -2 to the exponent 4. And that's -2 times -2 times -2 times -2, which is 16. So without a calculator, I was able to figure out what this is. Let's do it again. This is 9 to the -2.5. Well, 2.5 is not helpful. So I'm going to convert 2.5 to a fraction, and I have this now. Okay, split this into 2 parts. The fraction part, which is the half, and the -5 outside. Notice if I multiplied these two, I get -5/2. Well, 9 to the half is the square root of 9. I won't even put the little 2 because we know square root. Square root of 9 is 3. And so now I have 3 to the -5. That's 1 over 3 to the +5. And how much is 3 to the +5? 3 times 3 is 9, times another 3 is 27, times another 3 is 81, times another 3 is 243. All right, ready for the last one? Okay, I have a few things happening in the last one. I've got a fraction in here, I've got a fraction here, and it's also negative. I could work in whatever order I want. So I'm actually going to do this question in 2 different ways. Okay, so I'll go, here's one way you could do it. The one way you could do it is you could handle the negative exponent first, which means let me get rid of this negative exponent. Anything to a negative exponent is equal to the reciprocal of the base to the positive exponent. So let me take the reciprocal of the base to the positive exponent. Look what I did. I didn't change negative signs or anything. I just said it's the reciprocal of the base to the positive exponent. Now I'm going to split this out. So 4 over 25, I'm going to split it out to the exponent 1/2, and the whole thing is to the exponent 3. Right? Because 1/2 times 3 gives me my 3 over 2. Now, exponent 1/2 is the square root. So the square root of 4 is 2, and the square root of 25 is 5. So I have this. And now that's 2 cubed, which is 8, over 5 cubed. 5 times 5 is 25, times another 5, 125. Okay, so that's method 1. Method 2, same question. Okay, instead of dealing with the negative first, let me deal with the fraction exponent first. So I'll start with 25 over 4. Okay, to the 1/2, and the whole thing is to the exponent -3. All right, so it's the same thing, the same base, and then multiply the exponents, you get that. All right, so now 25 to the 1/2, well, that's just the square root of 25, so that's 5. 4 to the 1/2, that's the square root of 4, which is 2. And this is to the exponent -3. Okay, now 5 over 2 to the exponent -3, let me just draw a thing here. Okay, 5 over 2 to the exponent -3 is the same as 2 over 5 to the exponent +3. And here I have 2 to the 3 is 8, 5 to the 3 is 125. Okay, so 2 ways to do it, depending on what you want to tackle first, the negative or the fraction. Okay, so that's the end of the exponent laws. Now you've got all the integer exponents, and you've got 0, and then you also have the fraction ones as well, or the rational exponents as well. Okay, lots of practice in the booklet. Please do as much as you can. Thanks for watching.